Now, Stellar, I understand that none of you has worked with it. How many of you have heard about Stellar, read about Stellar? How many of you know Stellar? Okay, not many. Oh, some more.
Quite a few people.
And Owen, yeah, I know you know Stellar. So basically, Stellar, just like Bitcoin, just like Ethereum, is a distributed ledger, which is an ordered collection of transactions. And the thing about it that it has coin interactions in mind, which is true of Bitcoin, but definitely not true of Ethereum. It is not permissionless, so it's not as trustless. This is a good point that Oren makes. That you hear the word trustless a lot, but when we say trustless, we really mean not without trust, but that trust doesn't matter. That it's trust agnostic. So maybe it's not as trust agnostic because it is made up of federation of peers that do have a lot of it's very hard to cheat because there are many eyes, many people, many different interests. None of them, of the so-called miners, actually work for fee. The fee is distributed back as a form of inflation into the coin. And it's sort of, maybe it's a middle ground between the wonderful, idealistic, fully distributed, trustless, decentralized world of Bitcoin and the world that we have today. So in a way, it actually makes a lot of sense because it is clear that society is only getting ready to all this decentralization. And I hope that Stellar and the likes of Stellar can be stepping stones. But that's an important thing to notice, that it's not as purely decentralized and permissionless and I don't know if elegant is the right way, but ideologic as Ethereum and Bitcoin. Unlike Ethereum, the transactions are not free-form code in Solidity that you run. And unlike Bitcoin, like Bitcoin, it's operations, but unlike Bitcoin, the operations do not define a negative space of transactions. Now in Bitcoin, every transaction has inputs and outputs, and the value is actually what's in between. In Stellar, the operations that make up transactions there are 12 operations. You can see the list of operations in the documentation, and they're specifically designed for payment and value exchange. They even allow some, let's call it dark operations or highly centralized operations, like issuing a coin and having full control, having to whitelist basically anyone who works with it. So you can forbid people from using your coin. And this, to if you tell this to Bitcoin missionaries, they cry out. But basically, it's extremely practical, and I think that's a big part of the reason we use it. It just delivers. Stellar is used. It has the Stellar core. I guess this is the full node you would call, but the only interaction with it to the outside world is always through a Horizon server. Horizon is a web server. It's an API server that gives you all the communication with the base. So, and again, this may sound a bit strange, but it really makes things easy. And basically, even when we wrote it with Solidity, the first thing we did is set up a Swagger page, set up an API page, so you could use HTTPS and JSON to talk to it, and not, I don't know, Bitcoin it was RPC, right? So Stellar has this built in, and then specifically for our implementation, and this is something that we weren't absolutely sure about, but eventually we made a decision. And we wrote a Python library. It's called PAKET Stellar, and this library sort of helps you use Horizon. So it's even a second layer. The reason we wrote it is to make development faster for third parties. but it actually has another very important value, and this is the fact that we can always change the underlying L0, right? If we want to move back to Ethereum, we want to move to EOS, to whatever, we always have this API that is very packet oriented, that gives you the packet operations, and this way sort of translates currently to Stellar, used to be Solidity, and who knows what it's going to be in the future. Okay, so the biggest problem with Stellar, pretty much anyone you ask about it, it doesn't have smart contracts per se. So basically, we needed to okay, Stellar says that they do have smart contracts, but they're not that smart. The point is that you usually don't need extremely smart contracts. Usually, you don't need not even the full stack of script that Bitcoin uses that allows you wonderful things. But I think 99% of the users do not really need it. This can be actually viewed on the blockchain. Almost all of the transactions are the simplest kind of just moving Bitcoin from place to place. On Ethereum, you have very complex things, but again, many of them aren't really that practical. They're more gimmicky. And when what you have in mind is exchanging values, it turns out you don't need that many operations, you don't need that many options to solve a moderately simple problem like the one I described to you. So let's see what we do have and how we solve this problem, and I'm going to actually share the screen and show you some code. Does that work?
Yep.
Yeah.
You see code?
Yeah.
Yes.
Okay, so this is the library I was talking to you about, and I went straight to to prepare escrow, which is a bit of a monster. See, it's a lot of lines, 56 lines. It really screws up our statistics on Pilot. But here's how we do it, and it's not that complex. So the first thing we do is we create an escrow, and this escrow, okay, I forgot about that, I forgot to mention it, but another huge difference between Stellar and everyone else is that for pretty much anyone else, you only need to have a key pair, and this key pair can be used as an account. In Stellar, you actually have to create an account. An account does not exist until someone who has an account creates an account. And not just creates it, but actually funds it. You need to have the native coin of Stellar XLM inside your account. And this is hard. When you use testnet, you have services that you don't even need faucets. You have very, very easy, very practical services to get an account up and running. If any of you will start working with Stellar, I highly recommend the Stellar Laboratory, which has a nice web interface that lets you do pretty much anything you want to do with Stellar, and read all the transactions and decode them, and it's really useful. But it's still, once you go out of testnet, that means that every new client that we have will need to somehow fund his account with XLM, which is a coin that actually has value that we need to purchase. It means we need to have this funding wallet and a whole mechanism which is completely centralized of funding, of just being able to buy an account. And again, like I said, it's not as free and trustless as Bitcoin. That's one of the things where it is shown. So when you prepare an escrow, what you do is use some of your own XLM to create an account. And you create an account and you set it up to work with our coin, with a pool. And then you make up a bunch of transactions. Now, since I, as the launcher, created this account, I have full control over it. And the first thing I need to do is to receive that control. So this is here. This is the huge operation that you see here. It's a transaction with a bunch of operations. And as you see, it's last, because it actually requires us to already know what are the paths that we want the payment and the collateral to flow in. So there's a refund transaction, which is time locked. That's very easy. It's just like Bitcoin. We create this transaction and we give it. You notice there's a sequence. Every transaction in an account has a sequence. And this already has a sequence delta of 1. It will be, if the current sequence is n, this will be n plus 1. And of course, you only can increment it. And then there's the payment transaction, which has the same sequence. So only one of them can actually happen. And this one isn't time locked. You will see how it is locked later on, because of course it needs to be used only after the recipient signs it. And let's wait with this for a second. And then basically what I do is I create this big transaction with a bunch of operations that says that the payment is a pre-authorized transaction, and it has a weight. It means that any transaction that matches this hash, which of course is only one transaction, any transaction that matches this hash has a weight of 2. And then it goes with the payment, or it goes the refund, right? And the payment has a weight of 1. That means, and eventually right over here, you can see that we set up the different weights. We set up the weight of the master key, which is 0. We want to disable it. And then we have 3 thresholds. The low threshold and the high threshold are hardly interesting. They are meant for, the high threshold is for serious operations, about setting up thresholds, for example. The low threshold is really for meaningless operations. The medium threshold is for everything that's really important. It's moving value around. So you can immediately see that the refund, which is time locked, has a weight of 2. Once the deadline passes, this has enough weight to be authorized. And whoever has this can just publish it. The fee will be taken from the escrow account itself back to the launcher. Right? This is our refund. Also the collateral, which we enter into in a minute. However, the payment transaction has a weight of 1. And we have someone else who has a weight of 1, but this is the public key of the recipient. So as soon as the recipient signs this transaction, it can be used along with the weight of the pre-authorization to get to the value of 2, which means that this is a valid transaction and payment can be done. And again, this is payment along with returning the collateral. And then we have the merge transaction. This whole thing leaves one serious void, because I've created an escrow account, I've funded it with XLM, I've locked it and did all the pre-authorized transactions, and then of course I'm going to put my payment in it, and the courier is going to put his collateral in it, and if, on the case of a successful delivery, he's going to get his collateral and the payment. In case the deadline passes and there's no successful delivery, I'm going to get the refund and the insurance. But once that is done, we still have this dead account. And it still has XLM, it still has Stellar's native coin in it. And we need to be able to reclaim. Now, it's not a lot of money. The value of XLM changes annually, but really, we're talking about something between $0.50 and $3. But we still want to get that back. It depends on how complex the account is. I mean, every one of these makes it a bit more costly. But once we're done with it, we have the merge operation, which kills the account, destroys it, and sort of merges it into mine and gets back all of the XLM back into my pocket. Now, very important, if you ever get to work with Stellar and you need to use this trick, the merge is only possible when the wallet has nothing except for XLM. It can't have credit in any other token, and it can't even have trust in other token. It can't allow the sending of this token. It needs to say, I'm now a strictly XLM account, I only have XLM, and then you can merge it. So that's basically our escrow transaction, but maybe, and yeah, I totally missed that. But of course, the merge transaction has a higher sequence delta because it needs to happen after either the payment or the refund. And the original set options has no sequence delta. It works on the current sequence. So eventually, when you get these transactions back, the sequences on them are the set options is going to be the current one, the payment and the refund are going to be n+1, and the merge is going to be n+2. And if you happen to mix up the order, then your coins are gone. And in this, it's very much like Bitcoin, like the crypto we know and love. If you mess up, no one can refund you. Okay, before we move to the even more complex one, let's see if you have any questions about this. Was it even clear? I don't know. I'm swimming in this for so long. Maybe Owen remembers some things I missed.
Is this clear? Do you want to get to the deeper one, or stay this level? Maybe explain stuff about Stellar, or go to the next iteration. Stefan, what you say?
No, it's fine.
Thank you very much for this. Can you just explain us how do you handle time, tracking time?
The question is, how do you handle time in this?
So again, because Stellar is so practical and so built with these kind of operations in mind, it's pretty trivial. I'll show it to you here. Where's the refund?
He's using Vim. Anyone here uses Vim? Wow, several are using Vim around here.
Highly intelligent and competent people.
I still think you're all crazy.
Yes.
So here, this is the way. Oh wait, this is even the right one. This is the right one. This is how you handle it in Python with PyStellar, which is the official Python library to work with Stellar and Horizon.
But by the way, how many people here
By the way, we contribute to a bit. You have this function. It's called add time bounds, and you can say I did something clever here with this. If any of you are familiar with Python, so I needed to get this thing that returns actually, like, it needs to be an object. It can't be just a dict. So this is how you work with add time bounds. By the way, there is in the works. There's a version of Stellar that handles this even better. So you don't have to do the little dirty Python trick I include here. And you can always add memos for everything. This is fun. You can add short memos to your transactions, which appear in the blockchain. They're limited in size, but they really help you out when you go to explore the blockchain and you try to figure out who paid what and how it worked. This is rather helpful.
Yeah, Isal, maybe later you can show our web explorer and then zoom into a transaction and maybe show the memo.
Oh, sure. Yeah, we can do that now.
Yeah. So Israel is going to show you like a quick and dirty explorer that we did just to see the packages. By the way, there are more than 100 packages that that we did a proof of concept last month to deliver. Yamit, our COO, is just working behind, made sure that 100 packages arrive. We used local courier, we used trains, we used bicycles to deliver them. And we put on, Israel, make a quick explorer that you can see the packages. Can you put it on the screen? So if you go to paket.global is our website. If you go to explorer.paket.global, that's our website. You can see a map with heat map for demand, supply, and stuff like that. You can do it's very raw right now. And this is actual packages happening. This is a demo package that we did. Israel click that, and you can see we sent my business card that I forgot in Israel, and it went from Israel to Serbia. But if you click. But if you look at, maybe take another one or whatever that you can show the actual transactions for. If you look at the link here under delivery details, this long hash is the public key of the escrow account. So each package is represented by the escrow account that handling all the different tools. So if you click on it, I don't know if you want to do it now, you can see some of it, but if you click on it, you go to the regular Stellar Explorer. It can be any Explorer, and they start take it from here.
Yeah, and here are the thresholds. Remember, you saw them 1, 2, and 3. These are the 2 pre-authorized transactions.
We don't see your mouse, so if you can highlight, maybe we can see what.
Oh, okay. So, thresholds.
Yeah.
And these are the pre-authorized transactions. You see one of them has a weight of 2, one of them has a weight of 3. And this is the public key of the recipient, which has a weight of 1. And this is the public key of the original creator, which has a weight of 0, because as soon as we make it an escrow, we want to disable it. I don't want to be able to touch it. I need to be able to prove that no one can touch it.
That's what makes sure the packet.
A big part of the deal. That once you go around, you can, of course, we have this nice mobile application that will check this for you and show you that everything's on the up and up. But you don't need to trust anyone. You can just look at the distributed ledger. You can look at the so-called blockchain, and you can see that this key no longer has control. That all the money inside, and here the actual transactions happen.
Hold on for a second, Israel. The fact that the issuer gets a weight of 0, that's exactly the part that means that the packet project, that I cannot block any transaction. So if there's a transaction between you guys, of course, packet is not part of it. Or, by the way, any application that creates this can do the same. So actually, if you want to make sure, well, your application, of course, make sure of that, but the application can make sure that no one else can control the application, and you're really going to get the funds, whoever signs that's receiving the package. Sorry, go ahead, Israel.
Yeah, so here are all the transactions and the different operations that went through. You can see a lot of set options, right? Because we had all these pre-authorized transactions. You see a trust change when we trust Bull to the exact amount of the payment plus collateral to avoid the problem I described earlier. Right? If I go here, wow, it's fun. Yeah, so here is, you see that there's a lot of numbers. Back to this. Oh, we had here the list of